So as I mentioned on the last slide, a probability distribution is a distribution that shows you all possible outcomes of a trial and the probability that each one will occur. So this is actually going to look really familiar. So let's start with our crayon colors here. We're first going to list out the possible outcomes that we have. The outcomes are all different crayon colors. So in our first column in the probability distribution, we're going to list crayon color. In the second column in our probability distribution, we're going to list the probability of getting each crayon color. So first we have all our crayon colors. We've got red, orange, yellow, green, blue, and purple. We also have the probability that each one will occur. So we've got 0.083, 0.167, 0.167, 0.250, 0.167, and 0.167. And ta-da! That's it. We have a probability distribution. So we've listed out the possible outcomes that we have and the probability that each one will occur. So what you should notice here is that this looks really, really similar to a frequency distribution. And the main difference is that instead of listing the actual percentage of crayons that we're looking at, we're talking about the probability of getting a particular crayon. You'll also notice that if you add up the probabilities, they should come out to about 1. And here I was rounding, so this might be a little bit more or less than 1 if you're to add up these with the 3 decimal places. But the probability should come out to about 1. Make it consistent. And the reason for that is that you have a probability of 1 or a probability of 100% of picking any of these different crayon colors. And so what the probability distribution does is it tells you, in a nice succinct way, what's the probability of getting each of these outcomes. I also mentioned that probability distributions can either be based on what's known about a population or logic or theory. In this case, this would be an example about what we know about a population. So in this case, our population is 12 crayons. We know the exact number of crayons we have. We know the exact number of times each color appears. And so we're able to calculate probabilities based on this population. Another example of a probability distribution that would be based on a population, for example, would be if you were to take a random sample of people who live in the United States, you'd know the probability of getting a respondent who was, say, male or female, because we know the breakdown of the population in the United States in terms of gender. So that would be a probability distribution that would be based on a set of known population values. And again, just to say that one more time and to come back to this crayon example, this is a probability distribution based on known population values, where the population is just our complete set of possible outcomes, and our probability distribution is based on the number of different possible outcomes there are, and then the chances of getting each one we have here. And I don't want to jump the gun too much. We're going to talk in a little while about the relationship between a sample and a probability distribution. But just to keep this simple here, our probability distribution based on a population is when you know every single thing that's in a population or in some collection of outcomes, and you know the probability of each of those outcomes occurring. So that's one kind of probability distribution. So this would be one that's based on population values. The next kind of probability distribution that we can have is one that's based on logic and theory. So in other words, we know something about how probabilities work, and we can use that to come up with a list of possible outcomes and the probability that each one will occur. So this is 3 continued with our probability distributions. And so here what I'm going to show you is an example of something called a binomial distribution. And specifically, I want you to think about flipping a coin 2 times, or flipping 2 coins. So your trial, or the process that generates some kind of outcome, is 2 coin flips. The outcome that we're going to think about is the number of heads that we get in our 2 coin flips. So what are the possibilities when we flip 2 coins? Well, both of them can come up as tails, in which case we have 0 heads. One of them can come up as heads, in which case we have 1 heads. Or both of them can come up as heads, in which case we have 2 heads. And I left my coins in the other room, so I'm going to be right back. And I'm right back. Alright, so I've got 2 coins here. And what we're going to do is we're going to use logic and theory, in other words, what we know about how coin flips work and the rules of probability, to create a probability distribution that describes the probability of getting each of these different numbers of heads when we flip a coin 2 times. So I'm going to write out the table for our probability distribution right here. And then we're going to fill it in by calculating the probabilities. So the first thing that we have here would be a column for the number of heads. And a probability distribution, again, lists the possible outcomes that you can have, as well as the probability of obtaining each one. So when thinking about numbers of heads, we have these as our possible outcomes. You can either have 0 heads, 1 heads, or 2 heads. Those are the only possible outcomes we have when we flip 2 coins. What we want to do now is figure out the probability of each of these outcomes occurring. And in order to do that, we're going to use something we know about coins, which is that the probability of getting heads is equal to 0.5, and the probability of tails is equal to 0.5. So you know that when you flip a coin, it's a 50-50 chance whether it's going to land on heads or tails. That means that the probability of getting heads on any particular coin is 0.5. The probability of getting tails on any particular coin is 0.5. And with that, we're going to be able to figure out the probability of getting 0 heads, 1 head, or 2 heads. And we're going to start with 0 heads here. So as I mentioned before, there's only one way to get 0 heads when you're flipping a coin. And that's if your coins land on tails and tails. So in order to get 0 heads, we need to have this set of outcomes. We need to have tails on one coin and tails on another coin. And to find this probability, we're going to break down what we're calling one trial here, which is a flip of 2 coins, and we're going to think about this as being 2 separate coin flips. In other words, we want to know the probability of getting tails in one coin flip and tails in our second coin flip. So again, we're taking what is this single trial here of, a flip of 2 different coins, and we're going to break it down into the 2 component coin flips. So we got 1 coin flip and 2 coin flips. And we want to find the probability that when we flip these 2 coins, they're going to come up tails and tails. So here we're going to use the multiplication rule. And we know that when we're looking at an AND here, when we want to know the probability of getting one outcome and then another outcome, we're going to use multiplication. And so the probability of getting tails and then tails again is going to be given by the probability of getting tails times the probability of getting tails. And again, this is the multiplication rule that we learned over here, where the probability of getting one outcome and then another outcome in two independent events is given by the probability of one outcome times the probability of another outcome. So here we want to know the probability of getting tails and then tails again when we flip these two coins. And we're going to get that by multiplying the probability of getting tails times the probability of getting tails. And as a quick note, these would be independent events because your first coin flip does not in any way affect your second coin flip. Right? They're completely independent from each other. Right, so with our multiplication rule now, we can just plug some stuff in. We know the probability of getting tails is 0.5, and the probability of getting tails is the same thing, so 0.5. If we multiply 0.5 times 0.5, we get 0.25. This tells us that the probability of getting tails, and then tails again, is equal to 0.25 or 25%. In other words, we can fill in 0.25 here into our probability distribution. Because if we're flipping two coins, the only way to get 0 heads is to get tails and then tails. And we've established now that the probability of getting tails and then tails is 0.25. How about one head? Alright, so the next slot in our probability distribution that we're making is one head. And if you're flipping two coins, there are two different ways to come up with one head. I don't know what the right way to say that is. One option is that your first coin is heads and your second coin is tails. The other option is that your first coin is tails and your second coin is heads. So I'm going to write this like this. We have two options. One is getting heads and then tails. The other one is getting tails and then heads. So in order to find this probability, we're going to need to find the chances of getting heads and then tails, and also the chances of getting tails and then heads. So I'll start with the probability of heads and then tails. So again, what we're doing here is we're now sort of stepping away from this combined event of two coin flips, and we're thinking about this as being two separate events, where we're flipping one coin and then we're flipping another coin. Right now we want to know the probability that we're going to come up with heads on our first flip and tails on our second flip. So again, we're thinking about an AND here, and that means we want to use the multiplication rule. So to find the probability of getting heads on our first flip and tails on our second flip is going to be given to us by this probability of heads times the probability of tails. So of course the probability of heads is 0.5, as is the probability of tails, because it's 50-50 either way. So if we plug this in, we have the probability of heads times the probability of tails, or 0.5 times 0.5, and that gives us 0.25. So we have a probability of 0.25, or 25%, that we're going to flip a coin two times, or flip two coins, and we're going to get heads on our first try and tails on our second try. But we're not quite done yet, because we actually have two different ways of coming up with one head. So we don't have anything to put in our probability distribution up here yet. Instead, we have to find the probability of this second option, or tails and then heads, and then combine these together to get one overall probability of obtaining one heads across our two different coin flips. So we're going to look at our next option now, which is that first you get tails, and then you get heads. So here we're going to be doing more or less the same thing. We want to know the probability of getting tails and then heads, so we're going to use our multiplication rule again. And here we're going to be starting with tails, so we want to know the probability of getting tails for our first coin and heads for our second coin. So again, we're thinking about these as two separate events now that sort of make up this, possible overall set of outcomes. So here we've got the probability of getting tails times the probability of getting heads. Each of these are 0.5 again. And that gives us a probability of 0.25, or a probability of 25%. that we're going to flip our coins, and we're going to get heads on our first coin and tails on our second coin. But we're not done yet either. So now we have two different ways of getting one heads in our double coin flip here. We can either get heads tails, or we can get tails heads. So to combine all of this together and to find the probability that we're going to come up with one head when we flip the coin twice, we need to find the probability that we're either going to have this outcome here, heads tails, or this outcome here. When you're thinking about an or in a probability, what you want to do is think about the addition rule. So here what we're looking at is the probability of getting heads and then tails, or tails and then heads. So if you start with heads and then tails, so now we're thinking about in our double coin flip, so in this one trial of two coin flips, so we're flipping both of them at the same time, thinking about this as a single trial, in which we can get some number of heads. We want to find the probability that either we're going to have this outcome of heads and then tails, or that we're going to have this outcome of tails and then heads, because both of those are ways that we can come up with one head total when we flip the coin. So here we're asking or, what's the probability of one outcome or another outcome? We want to use the addition rule. And so specifically the probability of getting heads first then tails, or the probability of getting tails first then heads, is going to be given by the probability of getting heads and then tails, plus the probability of getting tails and then heads. If you do this, we have 0.25 for a probability of heads then tails, and we have 0.25 for a probability of getting tails then heads. And if you add these together, you get a probability of 0.50. So all of this work tells us that our chances of getting one head when we flip two coins is 0.5. In other words, there's a 50% chance that when you flip two coins at the same time, you're going to come up with one heads, which I did here just by chance. So there's a 50% chance that I would have gotten this outcome that I did. Alright, last but not least here, two heads. And luckily with two heads we're back to a pretty simple calculation, because there's only one way of getting two heads in two coin flips. And that way is getting heads in your first flip and heads in your second flip. So we're going back to only thinking about these two coin flips, and we want to know the probability that you're going to get heads and then heads again. So we're going to do the same thing that we did for 0 heads here, except that instead of looking at tails, we're going to be looking at heads. So what's the probability we're going to get heads and then heads again? Well, we can find this by using our multiplication rule, which again can tell us what's the probability of getting heads in your first flip and the probability of getting heads in your second flip. Here we can plug in our probabilities for heads, which are of course 0.5 for each. And here we've got 0.5 times 0.5, which gives us 0.25. So there's a 25% chance that if you flip two coins, you're going to get heads for both coins. And with this we can fill in our final value in our probability distribution, which now shows us the probability of getting each of these possible outcomes from a flip of two coins. You can check your work here by adding these up, and if you add them up, you get a total of 1. So there's a 100% chance that if you flip two coins, you're going to either get 0 heads, 1 head, or 2 heads. Those are your only options. So that is an example of a probability distribution that's based on theory and logic. And so what you should notice here is that it has the same format as our probability distribution based on what we knew about the population, where we actually counted stuff up and divided and calculated. So we have our possible outcomes in the first column, and we have our probabilities in the second column. If you add up all the probabilities, they should add to 1. And the difference that we have here between these two is that with this one, we found these probabilities by looking at the actual number of outcomes we have for each of these, and then the total number of possible outcomes we had. With this one, we calculated these probabilities based on what we knew about how the coins worked and what we know about how to calculate probabilities.